So then, what are you saying? How do we do this again?
The bottom one of the fraction,
Mm-hmm.
and then that on top of the radical thing.
Okay, that becomes the root.
Yeah. And then put x in there, and then 3 is x.
Perfect. Okay. For those of you who forgot, number one, there's a poster right here on the wall. And bottoms up. Bottoms up. Up. Yeah, right there. That's it. Hasn't changed. The years I've taught here. Okay, so bottoms comes up. Okay. Top just slides down to the x. And that's it. Bottoms up. Okay, bottoms up. So, easy, right? Easy. So, why don't you see if you can convert, what do we have here? Just the 4. See if you can convert the ones that have fractions to radical expressions. And the ones that have radicals to expressions that have rational exponents. Those fractions of the exponents, all right? Go ahead. Oh, nice. All right. Come to the first one.
Okay.
Come to the first
So
one.
guys,
Let's see if she's right.
it's bottoms up, right? So
Right.
it's going to be 5 radical y because the one is. It's the same thing. So
Perfect.
like,
Good. Thank you. And yes, I just want to let you guys know the proper terminology, what to call it, that's the root. That is the root of the exponent. Just like if I have this with no number, it's called a what root? Square root, because it's a 2 with a square root. If it's a 3, we call it the third root, fourth root, 5 is the 5th root. So you would say it's the 5th root of y, or 5th root of y to the first. So, come to the next one here. Now she had asked. You want to do it? Okay, go ahead. Let me get rid of this here. Thank you. Good. We probably, I know what you mean here. That's good. But when you write this, if someone else besides me is grading this, and really I should do this as well, you don't want to make it look like x times 7 fourths. You want to make it x to the 7 fourths. So make sure your exponent is here. I know what she does. I know what she means there, but you might get someone who doesn't know what you mean and say, "Oh, that's just times," and you're like, "Screw you!" and then you get in a fight and get thrown out of school. It's terrible. Wait to this next one. Okay. Yeah. Yeah. All right. You like that? You like what you put down? Why would it be over 2?
Because you don't have a number.
That's insanity. We're not trying to laugh. What? Oh my goodness gracious. There you go. Okay, better. Have a seat. You should write the exponent. I'm going to say that. You should write the exponent so it looks like it's definitely an exponent. This is slightly better because, see, the bottoms here are the same. That's a little bit off the ground here. But you want to say that's a B. It's the 5 halves. Now, that'll work. It's old school, but it'll work. Now, how do we know it's a 2? I don't see a 2. I thought if there weren't numbers there, it's a 1. Right. If it's not there, by default, it's a square root. So if you see any radicals without a number there, maybe you want to write the 2 just kind of mentally so you don't forget it's a 2 there. But this would be correct, which is kind of what this is. Okay? Who thinks they're going to last one here? Okay. Let's do this. Let's do this. You guys, it's not really bad. That is absolutely good. I like it. Now, okay. Wait, I know everybody's like, oh, I got it. I got it. I said, you don't even have to explain it, this guy. I got it. Let me explain it anyways. All right? Let me explain it anyways. Let's take this quantity that's in parentheses and let's just apply our rational exponent or our fraction exponent. So I know bottoms out 9, top down, but what's still left here? We still have x cubed y to the 7. I would have accepted that, but Ben went a step further and simplified it even more. When we have exponents raised to exponents, we need to multiply them together. 2 times 7, 2 times 3. So you still have the 9th root of x to the 6th, y to the 14th. And that's absolutely correct. Good. Good. Simplifying rational exponents expressions, okay? All answers should be left with a radical, not a fraction in the exponents, okay? Now, I'm going to repeat that. When I simplify these, I want my answer to have the radical in it. I don't want my answer to have the fraction. For now, okay? So does anyone remember, how would we simplify this first one here? Go ahead. Take the square root of what? Okay, so you're taking the square root of what first? Okay, and then what would you take the square root of next? And then what would you take the square root after that? Okay, yeah, I'm going to break up all these terms and put them under their own radical sign. I'm going to. It's a lot easier to apply that square root to each of them individually, and then I can just put them back together. Right? It's a million times easier. I mean, that's the way I do it. Some people can look at that, and because they know the rules, don't have to show work and can just give me the answer. Okay? Maybe if wasn't getting a little bit more comfortable with this. I know it's the first day. When we get a little bit more comfortable with this, we can do that. But for right now, I'm going to have the square root of 25, the square root of x to the 5th, and the square root of y to the 4th. Now, let's do the layup first. The beginning. What's the square root of 25?
5.
It is 5. That is done. That's going to be my answer. Now, what is the square root of x to the 5th? Who remembers what we do? No? No? Well, no, look at it. Let's do this. What if we convert this back to a fraction if that's easier for you? What would the fraction be?
It will be x to the 5th of 1. No, x1 over 5. Oh, 2 over 2, yeah.
5 over 2, right? So, it would, and I'm going to go off to the side. I'll do this right here. This will be x to the 5 halves. That's a fraction. Fraction represents what mathematical operation?
Division.
Division. What is 5 divided by 2? 2.5. So it's 2 with a remainder of?
5.
Stop it. 2 with a remainder of? 1. It's 2 with a remainder of 1. Remember we did this last year. Okay, 5 divided by 2. It goes in there twice with a remainder of 1. 2 x's would come out, and 1 x would remain in the radical. Okay? There's so many different ways to do that. I'll show you another way visually. Question. If I had the square root of x squared, what is that? Well, if there's a fraction, would that be x to the 2 over 2? Which is just x? Right? If the numbers on the outside and inside match, it's just itself. So, we have 5 here, don't we? Can I say that's like x squared times x squared times x to the 1?
Yeah.
All right? So, wouldn't this just be an x? Times this Would it just be another x? Because for every time they match, 1 comes out. And then this is just left over. And what's x times x? I just divide them, though. To me, it's easier. I divide. What's my quotient? 2. That's what comes out. What's my remainder? 1. My remainder, and I can't say this any easier. My remainder is what remains under the radical. Thank you. Now that we did that, let's take a look at y to the 4th. Okay? So I know that this is going to be my answer. Y to the 4th. How many y's? Let's simplify that. There's 4 y's, but isn't this squared?
Yeah.
The what? Yeah, no, you're right. What is 4 divided by 2?
2.
2. So that's how many come out of the radical. What's my remainder?
No remainder.
There's no remainder. It's 0. So that's how many remain under the radical. None. 0. There's no radical there. Because if I change this to a fraction, isn't that y to the 4 halves? Isn't that just y squared?
So it's just y squared.
It's just y squared. Because the remainder is 0. So nothing. 0 remains under the radical. So all I want to do now is just put this all back together. Everything that's outside of the radical will be together outside the radical. Everything that's inside the radical will be under the one radical that you write. Here it's just one term.
So just x squared.
Well, let's write it like you would see on a test. Numbers, big coefficients first. 5. And then we write our variables alphabetically. X squared is outside, and so is y squared. And then I do this for my radical. The only thing under a radical is my x. There you go. That's your answer. That's your answer. No, it wasn't that hard at all because I had to re-explain it. Now, let's go back to the original problem and see if we really had to break this down. Breaking it down is nice because if you go too fast, you're going to make a mistake. All right? So let's do this slowly, our thought process. Some people can, again. All right, well, let's think about this as we do it. If I have a 2 here, a square root, I know the square root of 25 is 5. Okay? I know I'm going to have y squared because 4 divided by 2 is 2. I know that 2 goes into 5 twice. So 2 x's should come out, but I have a remainder of 1 there, so 1 should stay in. I mean, you can do it that way if you get it. If you get it good, you can just do it that way. But remember, if I'm grading this, and it is not multiple choice, I can give you credit if you have some work correct, if you show work. If you don't, if you just have a wrong answer. Can't give you any credit with no work. Okay? That's how it is in the final, so that's how I got to have it for you guys. Now, the next one is going to be a little bit more challenging. It's still the same rules apply, though. The same rules apply. Okay? So, how do you want to start this? There are 2 ways to start this. Anyone have a preference?
How about you trying to do it backwards? It's already in the answer. You trying to put it back in the radical? No question.
Well, if I want a radical in the answer, I can put the radical back in there now and convert it, or I can just distribute my exponent. I can multiply my 1/3 times everything, and then just put the radical in at the end. I can do it either way. It doesn't matter. I heard this story. I don't know. Whatever way you'd like better. Do the radical now. I'm hearing. Sorry. I know he said. I know. I don't even know why I asked. You know what I mean? All right. So don't forget, this is the cube root, right? This will be the cube root, and everything will be to the power of 1. So it's 16 x to the 7th, y to the 11th, to the power of 1. But I don't really have to write the power of 1. I don't have to write an exponent if it's 1. So now we're going to do this the same way we did the first problem. What should I do here?
16.
Yeah, I'm going to take the cube root of all 3 of those terms individually and put it back together. All right? I've got the cube root of 16, okay, times the cube root of x to the 7th times the cube root of y to the 11th. Right now, unless 16 is a perfect cube, which it is not. It's a perfect square. Don't tell me it's 4. Oh my God, don't tell me it's 4. I know, some of you are going to. That's a cube root. Now, look at our first problem. This was easy, because the square root of 20, that's easy. But now when the number isn't so obvious, it's easier to do the variables, because you just divide them, right? Let's do our variables first, because you guys should be able to do this nice. Let's look at the cube root of x to the 7. Okay? You guys tell me how many come out, how many stay in. 2 come out, 1 stays in. Because I take 7 and divide it by 3. 3 goes into 7 twice with a remainder of 1. Okay? 7 divided by 3. It goes there twice with a remainder of 1. So 2 come out and 1 remains in because that's a remainder. So this would say x2 come out and 1, I don't have to write that 1, but I'm going to, stays in. What's one thing I did wrong there when I wrote that in black? The what? What's the one thing I did wrong there? Why would that be wrong? It's a cube root. It's not a square root. So make sure you write your cube root there. Sorry, that's lucky. That is x squared times the cube root of x. It's not times the square root of x. If it was square root, I wouldn't have to write the 2, would I?
Okay.
But it's a cube root. I have to write the 3. There you go. Easy. Why don't you guys tell me what the y is? Who can tell me what that y is?
3.
Okay, so 3 come out with the remainder of 2. 2 stay in, and let's not forget, that's a cube root. That's a cube. I mean, look how easy the variables are now. Nah. 16 is not a perfect cube. How do we break down numbers under radicals? It's just a number.
Don't you just try to figure out what 2 numbers is? And how we can regular?
Yeah, okay. Yeah, 2 numbers that make a perfect square that go into it. But we're not dealing with squares, are we?
Perfect cubes.
Perfect cubes. What are my perfect cubes? 1 is a perfect cube because 1 times 1 times 1.
8.
8 is a perfect cube because it's 2 times 2 times 2. Okay? What is 3 times 3 times 3?
9. No.
That, 27. 27 does not go into 16.
It's not 12. Oh.
Don't look it. Don't add that last 3. Don't multiply 3 times 3, which is 9, then add 3. It's 3 times 3 times another 3. Now look it. Look it. We need to find the biggest perfect cube that goes into 16, and what is it? 8. Because the cube root of 8 is 2, because 2 times 2 times 2 is 8. So I'm going to break this down. I'll break it down, TJ Lance. Come on, no one watch that. Stop it. I don't have you guys left. You'll have a gap. I don't have you guys. All right. So I can say that's the cube root of 8 times what?
Times 2.
Times the cube root of 2.
I was right.
Because if they have the same roots, I can multiply them together and put them under the same radical. This would give me, if I multiply these 2 together, that would give me the cube root of 16. Just like I can multiply them together, I can factor them, as long as they're the same root. And what do we say the cube root of 8 was? This is going to be in my final answer. I can't break this down anymore. That's going to be my final answer. This is going to be my final answer. And this is going to be my final answer. So let's write this. What are the terms? Now when I'm all done, I'm going to have some things outside the cube root and some things inside the cube root.
So it's going to be 2.
Okay.
Why 2?
It's going to be 2. That's outside the radical. What else? X squared. And what else? Y cubed. Those are all things that are no longer underneath the radical. What are things that are still underneath the radical?
It's going to be 2.
2. What else? X. I don't have to write that exponent 1. You can, but why waste energy? And y squared. And that's absolutely done. Now, I mean, it's not, but I know you're rusty, it's got to be re-explained, but it's not horrible. Now, who can remember from last year why I put the parentheses there.
Like post.
What?
So that it's different, so that it's not together.
Thank you. If I write this, 2x squared y cubed, cubed root of 2xy squared. I mean, is that y to the 33rd? Is that the 33rd root, or is that y cubed times the cubed root? Or is it y cubed to the 3rd power? I don't know what that is. But if I do this, I know exactly what it is. There's no argument. Okay? So, see the blinker, this cursor's blinking, something's happening here. There's like some magic button. So, why don't you guys try these 6 problems? 6 problems, have fun, and we'll go over the answers. Okay. All right, so, like I said, we'll go over a couple of these. The rest I want you to finish for homework. So, what is the biggest square, perfect square that goes into 288?
120. 11. 121.
Close. Stop it.
Oh yeah, I didn't go down. 144.
144. 128. That's 144 times 2. Since my 288 is in a radical, those two numbers are going to be radicals as well. And what is the square root of 144? 12. So my answer, 12 radical 2. All right? That was a simple one. What about the square root of 2x cubed y to the 4th? Well, first of all, can I take the square root of 2?
No.
No, so that's going to stay in the radical. What is the square root of x cubed?
I only got 1.5. We put 3 divided by 3 is 1.5.
Yeah, but just divide it without using your calculator. Divide it. Figure out what's the quotient, what's the remainder. That is. X. First of all, 2. Listen, 2 goes into 3 once. So 1 stays out with a remainder of 1. So 1 remains in. Okay. Now what about my y to the 4th? It's just y squared. 2 goes into 4 twice. So when I write that,
It will be x times y squared.
It's
Radical over 2x.
xy squared, and then parentheses, everything else is under the radical. I have a 2 and an x. There you go. Not that crazy. The thing that tricks some of you guys up is you see the square root of 2 and you think it's 2 or 1. 2 is not a perfect square. All right? We'll do one more and the rest will be for homework. This is nice because the cube root of 8 is perfect. What is the cube root of 8? 2. What's the cube root of x to the 6th? X squared. What's the cube root of y to the 4th? Y. The cube root of y. So your answer is 2x squared y cube root of y. There you go. Have a good one the rest